That was hard.
Okay, good morning. Any questions, anyone? Questions? Yes?
For the midterm that was on Thursday but isn't anymore,
Yeah.
what day is it going to be?
I don't know yet. I'm trying to get where, because all the instructors in all sections need to do it together, and some of them are slower than others in getting back to me with where they are in their class and when they want to give it. My best hunch at this point is Tuesday after next.
The Tuesday after next Tuesday?
Yes, next Tuesday. That's my best case, but no promises. We will have arrays on it, so we have to at least cover a little bit about arrays together. So it definitely will not be today or Thursday. And I think I'm not going out on a limb by saying it's probably not going to be next Tuesday either. But 9 days from now is probably the earliest. But that could happen. Other questions? I wanted to go over one algorithm that's an important algorithm that involves loops, and that we'll see again when we do arrays, namely to find the largest element in a sequence. So let's say I'm reading a bunch of numbers. And at the end I want to print out the largest one. And so just to have some example, let's say that the numbers that are being read in are 1, 4, 29, 7, minus 2. Just like that. So and how do we know when the numbers finish? Let's say afterward we just put the letter Q. That's going to make has next double false, and that way the loop ends. So this is here a sample end. So what would I do to find the largest of these values?
You could go through each number one at a time.
Which I do, right?
Right. And then store the current value in some sort of variable, and then run some sort of if or while statement that says, like, if this value, if the value currently on is less than the previous value or greater than the previous value.
Right. So it's kind of similar to what we had in the homework, where we compared the value with the previous value.
Mm-hmm.
If you look at the last at that hard homework assignment where you had to read in all these values and print whenever there was a decrease, you compare two values. You compare the previous and the current. But here it's going to be a little bit different. And you don't just want to look at the previous one, because if I look at the previous one, I compare 1 and 4. Well, the 4 is larger, right? 4 and 29, the 29 is larger. 29 and 7, the 29 is larger. But then when I look at 7 and minus 2,
it'll think that.
Then, so I don't want to forget the 29.
Yeah.
So instead of just remembering the previous value, which value should I remember?
The largest.
Yeah, the largest one I've seen so far. Right? The largest one I've ever seen. If I remember that one, then I'll be good. So, and here I call it the largest. So I need to compare x and the largest. And then depending on how that comparison goes, I need to update something. So when do I want to act? X greater largest, X greater equal largest, X less than largest, less equal.
Greater than largest.
Okay, so greater, this makes sense, right? In this case I say, if I see one that's larger than the largest one I've seen so far, well, that one must be really large. So I'm going to be really interested in it. So in this case, what do?
Make X into the largest.
I was hoping someone would say that, because that's a common mistake. What's wrong with that?
X is the next value.
X is the next value, right? So what do I want to do? What I want to do is I want to remember the one that's the largest one all the time. It should be the other way, right? Because I want to say, well, if X is bigger than what I thought was the largest, then I was wrong. Then there's a larger one. And so I need to update it. So I've now seen an even larger one, and I need to store it in what's the largest. Now finally, how do I initialize largest? So far, I need to put it up here, right? How do I initialize?
Min, right? Is that what we did last time? And whenever you're trying to
Here's a man with good memory. So what he remembered is we had kind of the same problem before. We were updating this data set one element at a time, and at that time we set largest to what was integer.max value or integer.min value.
Min for the largest, yeah.
You said we used min for the largest. That makes sense because when we saw the next one, then it would be bigger. Now, so that would be a good suggestion if I could do that. So the correct term for this is integer.min value. I think. Don't worry if you don't remember the exact way that it was called, as long as the kind of basic idea is stuck in your mind, like it did for Mark, then that's great. So, and that would be nice, except it only works for integers. It doesn't really work for floating point numbers. How big is integer.min value? Approximately?
-1 billion.
He said about -1 billion, and I mean, he's pretty close. It's -2 billion and change. But for an integer, that's pretty negatively large. But for a floating point number, that's nothing. I mean, floating point numbers can go up to 10 to the 300. So they could be much, much larger. And there is unfortunately no constant that gives us the largest floating point number. So the floating point numbers, we can't use this trick of making it the largest negative number. And that's the problem with floating point numbers. Instead, what we're going to do is we're going to initialize it by reading one value. That way it's going to be an actual value. Oh, why don't I initialize it to 0? But that's something that students like to do all the time.
Well, I mean,
It would work here, right? If the 0 would immediately be replaced by the 1 because 1 is larger.
right.
What if they're all negative, right? What if I'm trying to find out the largest of some temperature series in Alaska? And they're all negative. And then, they would probably kill to actually have 0 degrees. I have no idea. I've never been there. So that doesn't really work because if you have all negative, then it's not going to work. So the safe thing is to pick the first value and initialize it with that. Now let's see who's a budding computer scientist here. The budding computer scientist at this point would say, but what if there is no first value? Thank you. There he is. What if there is no first value? What if the user simply entered the series Q?
Wouldn't it just not, like the while loop just wouldn't even do anything?
Well, not only would the while loop not be entered, but our program wouldn't even get there because it would have died already here.
Right.
And so that would not be very good. And so this is a bit of a philosophical question. Does it make sense to compute the largest of an empty sequence? And given that we don't really have such a thing as a most negative value, we're going to take the attitude that doesn't make sense. And so all the way up here, we're going to say enter values at least one, then Q. We're going to define this problem away. We're going to say that to compute the maximum, one has to have at least one value. And that's because we don't know in this particular situation what to report otherwise. Sometimes you can, like with the numbers, you could say, well, if the sequence is empty, we'll define the maximum as kind of that negative infinity. But for floating point numbers, that's kind of difficult. So we're just not going to do. So this is kind of a very common algorithm that you'll find all the time. Whenever you need to compute the largest of a sequence, you need to remember what is the largest you've seen so far. Now, of course, when you get this algorithm, you're probably not going to be getting it in this exact form, but you're going to get some slight variation of it. So let's have a variation of that, and that is, let's not have the user type in a bunch of numbers, but I'm going to ask the user to type in a bunch of strings, at least one. And then I want to know what is the longest string that they enter. So over here, they'll enter something like hello, goodbye.
What happens if there's two strings with identical lengths, though?
Okay, we'll get to that. Fred and give me a string with 7 letters. Letters. Yeah. All right. So, and we're going to say that they're going to have to keep entering them. How do we know they're done? Now I can't just say int dot. So I'm going to. Okay, this is going to be a little more complicated. So I'm going to have to erase a little bit of this. So previously, they were able to enter the letter Q, and then the Q triggered the has next double to be false. But so now I'm going to read in the next string with has next. Oh, sorry, with next. So it's just next. So I'm going to read it in with just next. And that messes up my while a little bit. Because there's, if I were to say has next, well, there's always going to be another possibility to enter another string. So how should I terminate? We have the same issue on another homework assignment where there was a descriptive string, and then we had some other funky way of ending the input. How do we do it there?
had a trigger word end, right?
It's a trigger word end. Okay, let's just do the same thing, right? So now I'm having this issue. When do I terminate? I have to now first read it, and then I have to see was it end. That's a little nasty, right? I can't check at the top of the loop. I have to first enter the loop, read my word, and then I'll know. So over here, let me just cram in this test. So if x equals end, then what do I do? What do I want to do?
You wanted to like saying you wanted to break out of the loop. You're breaking it out of the loop once it
I would
reaches
like to
the
break
end.
out of the loop, right? Except we're not allowed to use break because it's considered an evil keyword.
Use done.
Ah, exactly.
So well not
So in this case, I have to say, done equals true, and I do the while not done pattern. Excellent. Okay, and then else. I have to now put an extra set of braces in here. It's maybe a little bit tedious, but it's a clear recipe that you can always use. Every time you have one of these loops where it's a little bit complicated when you leave the loop, that Boolean variable trick really helps you out. Set a Boolean variable done, and as soon as you find that you're ready to leave, you set done equal true, and then eventually you're going to get out in an orderly way. The advantage of doing it this way over a loop that has a bunch of breaks in there is once the loop gets a little bit more complicated, like in that homework 18C, where there's 2 or 3 different cases when you want to get out, then the break stuff really does get messy and people make a lot of mistakes. And I cannot find that the people who use break were any more successful. I had a peek this morning at the submissions for 18C. If anything, they look messier and wronger than some of the others. So I'm going to give you one final chance for that thing, but please without breaks and without continues. Yes, the pain never ends. So I'm not even going to try to explain what continue does. There are very few programmers who use continue because most of them find it ultimately confusing and not all that useful. So do it without. All right, so here we now know when we're going to end. Now let's move on. So we have a largest string. Now actually, in this case here, with a string, it's kind of easy. We can start out with the empty string and say that is surely the smallest string that there is. Because unlike with floating point numbers that can go on more and more negative, strings actually have a shortest string. So now I have x, that's my new string. I have largest, that's the largest string I know so far. And I want to check whether I should go and do the replacement. But now there's a problem. I can't use greater than with strings. Yes, I have to compute their length. So over here I would say if x dot length is greater or largest dot length. And so that's kind of a typical change that you have to go through when you want to compare things other than numbers. You have to figure out how to compare them, and this if condition has to have the right comparison. Here I'm comparing their lengths. Now I might have a sequence of rectangles, and I might want to find out which is the rectangle with the biggest area. In that case, I would have to compute the areas and compare the areas. The basic loop would be the same, but the details of the loop are different. All right, so that's the segue into